if you are preparing for this examination and following my videos, please like, share and subscribe. We now discuss the solution of a problem from the section Number Theory, broadly from algebra. This question has appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the congruences. This question is from the section C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704084. The given question is, let n belongs to Z, the set of integers, be such that n is congruent to 1 mod 7 and n is congruent to 4 mod 15. Which of the following statements are true? N is coming from the set of integers, satisfying n is congruent to 1 mod 7 and n is congruent to 4 mod 15, then which of the following statements are true? We are given 4 options. Option 1, n is congruent to 1 mod 3. Option 2, n is congruent to 1 mod 35. Option 3, n is congruent to 1 mod 21. Option 4, n is congruent to 1 mod 5. Right. We will now discuss the solution of the problem in detail. We have n belongs to the set of integers and n satisfies two congruence relations, and they are n is congruent to 1 mod 7. That means 7 divides n minus 1. That means n is 7 times k plus 1, where k belongs to Z. Similarly, n is congruent to 4 mod 15. That is 15 divides n minus 4. That is n is equal to 15 times m plus 4, where m belongs to the set of integers. Now, for what values of k and m? 7k plus 1 coincides with 15m plus 4. So, we go and search for those k and m for which 7k plus 1 is equal to 15m plus 4. So, they are equal. That will imply 15m plus 3 is equal to 7k, where k and m belongs to Z. Now, for what values of k and m? 15m plus 3 is equal to 7k. There will be several values of k and m. One of my observations will tell you, when k is equal to 4, it is 15m plus 3 is 63. Then I take k is equal to 9. 7 9s are 63. So, on observation, this is satisfied for m is equal to 4 and k is equal to 9. Therefore, what is the value of n for these values of m and k? So, n is equal to 7k plus 1, where k is equal to 9. So, 9 7s are 63 plus 1, that is equal to 64. So, n is one such integer which satisfies these two congruences. Now we take this n is equal to 64, go on verifying the options. Right. Now you can arrive at this answer 64 and other values of n using, the famous Chinese remainder theorem. This is a systematic way of finding the solutions of congruences. And I can also use Chinese remainder theorem, but it will take little bit of time. But it is the question of the time management. Therefore, I have preferred to take this kind of a route. And this method works, if you have two congruence relations, very simple two congruence relations, then it will not be difficult to find k and m. Right. You can also do. So now we go to the options. So n is equal to 64. So 64 is congruent to 1 mod 3. That is 3 divides 64 minus 1. Yes, 3 divides 63. Right. So in every option you have n is congruent to 1 mod some positive integer. Right. So n is congruent to 1 means you have to talk about n minus 1. For n is equal to 64, n minus 1 is 63. Then you have to see 3 divides 63. Correct. Option 1 is true. 35 does not divide 63. Option 2 is false. 21 divides 63. Option 3 is true. And 5 does not divide 63. Option 4 is not true. So we take first 64 is congruent to 1 mod 3 because 3 divides 64 minus 1. That is 3 divides 63. Therefore option 1 is true. And option 2, 64 is it congruent to 1 mod 35? So 35 divides 64 minus 1, that is 63, but it is not. 35 doesn't divide 64 minus 1. Therefore, 64 is not congruent to 1 mod 35. Option 2 is not true. And option 3, 64 is congruent to 1 mod 21 because 21 divides 64 minus 1. That is 21 divides 63. Therefore, option 3 is true. In the case of option 4, now 64, is it congruent to 1 mod 5? No, because 5 doesn't divide 64 minus 1. That is 5 doesn't divide 63. Therefore, 64 is not congruent to 1 mod 5. Therefore, option 4 is not true. Summarizing, the answer to this question is option 1 and option 3. That is the detailed discussion of the solution of the given problem from the section number theory based on congruences, and this question is broadly from algebra, from the section algebra. So in the syllabus it is mentioned under algebra. And I reiterate that you can systematically obtain the solutions of the congruence relations by using Chinese remainder theorem, but it will take a little bit of time. Therefore, and if the congruence relations are few, that is 2, only more, so not more than 2, if there are 2 congruence relations, then it is easy, to follow this kind of a method. So that is the detailed discussion of the solution of this problem. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.